To begin this next lab, you have a couple of routers with working interfaces and IP addresses already configured. Your job is to configure OSPF, following some rules, including using OSPF interface subcommands. Let's do it. All right, for some context, the official Cert Guides, Volume 1, Part 6, Chapter 22 of the current edition is where you could find deeper background on this topic, but it's the OSPF configuration section of the book at whatever edition. So this lab, you see the direct link to the lab here. It's a blog page in my blog. It's titled OSPF Interface Config 1. So all of these blog web pages have basically the what to do at the top, the scenario and tasks, and then a very short section that says do the lab. You can do it in Packet Tracer or CML. And then at the bottom is the answer and an explanation as to why I think that answer is correct. Now the videos go a little deeper. I've got this intro video that goes a little deeper on what to do. And then there's an associated lab review video that goes a little deeper into the answer. Let's talk about the starting point for the lab. You've got 3 routers that have some configuration already. As far as the topology goes, they're connected with WAN links between each pair of routers. The WAN links will have gigabit interfaces 01 and 02 connected. So we see gig 01 and gig 02, gig 01 and gig 02 on those WAN links. Then on those 3 WAN links, we have 3 different subnets of network 172.30. All 3 subnets have a mask of /30. That is, they've got 2 usable IP addresses per subnet, and you can work through that math as an extra exercise if you'd like to do that. But you'll see the configuration for the addresses on the lab's blog page. All right. There's also this gig 00 interface on all 3 routers, and those are the LAN interfaces, which are connected to a switch that creates an Ethernet. All the devices are in one VLAN and one subnet. So we've got a sample PC up there that's in subnet 172.21.10 with a /25 mask. And over here off router 2, there's a different subnet, different PC, and a third subnet with a third PC down here. Now the figure doesn't point out the specific interface IP addresses, but the initial config on the blog page does. So there's a hostname command for all 3 routers to set the host name. And each interface has a no shutdown command confirming that administratively, at least, the interfaces have been brought up. They should all be in a working up state, but you could verify that. Then there are individual IP address commands, so you can see the individual IP addresses chosen in each case. So you could check your math, for instance, if you decided to do that subnetting math. Now, it doesn't fit on one page to show all 3 routers' initial config, but if I ignore the shutdown and no shutdown commands and the comment lines, I can cram all 3 routers' IP address configuration onto the same page. You can hit pause and peruse those, or look at the blog page, and you see 3 interfaces on each router in the drawing, 3 interfaces on each router in the configurations with their individual IP addresses. So what are you supposed to do in this lab, right? So here's a reminder of the topology and the subnets. First off, enable OSPF on all 3 routers with these instructions. We want to use area 0 only, so all interfaces are in area 0 as shown on the left. And we want to use, quote, interface subcommands, meaning don't use the network command in router config mode. Use the alternative, which uses an interface subcommand that I'm not giving away, so you can go do lab, all right? So enable OSPF on all those interfaces. Additionally, use configured router IDs, and it says do not rely on interface IP addresses, so just configure those directly. What do you configure? 11112222 and 3333, respectively, to match router numbers 1, 2, and 3. Last up, it doesn't say anything about what OSPF process ID to use, so you can pick. All right, so we'll leave that to you, and I'll talk about that in the review video. All right, so what else about the instructions? Well, there are some key assumptions. All the interfaces are up and working. They've been configured with IP addresses. That is, the initial configuration we just talked about is already there. But it doesn't hurt to verify that's true when you first open up the lab, whether that be in Packet Tracer or CML. And speaking of Packet Tracer and CML, if you're using Packet Tracer, go to it. Go to the lab now. If you're using CML, hang around and we'll talk about that with a few extra comments to get you started. So one of the first things to think about with CML is that the routers in CML don't support the same interface ID conventions as Cisco Packet Tracer. The lab is written assuming Cisco package tracer. All right, so on the left, you see a repeat of the lab topology with all these interface IDs. However, in CML, we can't use those. However, we can use almost identical interface IDs. All the instances of gigabit 00 become Ethernet 00, gig 01 becomes Ethernet 01, gig 02 becomes Ethernet 02. Very easy to correlate, all right? And I'll just redraw the figure so you see instead of the G's, we see an E there for the interface ID. The last thing to talk about has to do with an optional testing step you don't have to do, all right? But here's the deal. Do you want to test from those end user hosts, the PCs? Well, in CML, it takes a little extra work. And if you hear what I'm about to say and you look into it, you can just say, no, I'm not going to bother. You can say, maybe I'll try it a little, or yes, I'll do it, all right? But what's the deal? Well, there's a 5-node limit, 5 active node limit in CML-Free edition. So to overcome that, here's what I design into labs like this one. We've got the original 3 routers. That counts for 3 against your 5-node limit. We've got these 3 switches, and you might think, oh, we're already past our 5-node limit if we've got 3 switches. Well, these will be what we call unmanaged switches in CML that don't count against the limit. So far we've used up 3 against our limit, but if we were to put 3 PCs out there, those count against the limit. That would put us at 6 nodes. That's too many for the free version of CML. So what I've done is taken one router, configured a feature called VRFs, and use those instead of one PC, so that if you ping and say, I want to ping as if I'm PC 1, the message really will go in this way. And if I say I'm going to ping as if I'm PC 3, it'll come in through switch 3 to router 3. And if I say I'm going to ping as if I'm PC 2, it'll come into switch 2 into router 2 like that. All right. I've got a couple of videos that get into some detail about how that works, but it's up to you to decide if you want to bother using it. But as an end user, you could just say, hey, I'll at least give it a try. And here's what you could try. First off, R1's gig 00 IP address happens to be this 172.21.1.1 address you see on the upper right box. So if you connected to the console of that one router as many hosts and did this command, ping, as if you're host 1 being the generic way to refer to PC1, ping as if I'm host 1 to R1's LAN address, then that would send a ping as if PC1 had sent it, and it would come into R1 and come back out. Or if I tried this command, again from this router as many host router, ping VRF host 2, it tells it, hey, ping as if you're on PC2, and it would send the packet into router R2, who would route it to router R1. It would come back this way. So we're testing the network still, but we're using this hook and crook deal with this router as many hosts with an advanced configuration in it. Same thing, ping VRF host 3, ping as if you're host 3, the packet would come in here, get routed, and sit back. So it's useful for testing, but it may be more than you want to get into in a lab, and I respect that. So just to recap, why do we do this? Most labs with hosts in them are going to have more than 5 nodes and blow past the CML-free 5-node limit. If you want to know more, look in the description or even above my head right now here in the video for a link to watch more about this router as many hosts feature and decide if you want to bother using it or not. Hope you enjoyed the video. If you want to click through and click to the Config Lab review video, do that. Of course, do the lab as well. And there should be a link to another video of related content. Hey, thanks for hanging out. I'll talk to you soon.